This is the National Weather Service in Elko, here to bring you a weather brief about the winter outlook. First, a quick review of last winter. Thanks in large part to a deep snow cover which developed just before a strong ridge of high pressure settled over the region, last winter averaged below normal across much of Nevada temperature-wise. This was mainly due to cold air which became trapped below the strong ridge and persisted due to the deep snowpack in place at the time. January ended up being one of the coldest on record, offsetting other months during the November to March period, which were near or above normal. Despite the deep snowpack which developed by early January, precipitation during the November to March period still ended up below normal. As an example, we list the actual departures in Elko, which showed an average temperature of 0.7 degrees below normal and precipitation nearly 1 inch below normal. Here are the water year precipitation anomalies across the United States during the past 2 water years. Both were drier than normal across the western United States in general and Nevada in particular, though this was certainly more pronounced 2 years ago than it was last year. Nevertheless, due to 2 back-to-back dry years, Nevada remains in a significant drought. All of our region is listed to be in at least moderate drought, with western areas in extreme to exceptional drought, as depicted by the U.S. Drought Monitor. So, will we see any improvement to the drought this year? Possibly. Let's take a look at the clues we have locally as to what kind of winter we will have. First, we'll review the El Niño Southern Oscillation phenomenon, called ENSO for short. El Niño and its counterpart, La Niña, refer to the periodic fluctuations in water temperatures in the eastern equatorial Pacific Ocean compared to normal. El Niño refers to periods when the waters are significantly warmer than normal, while La Niña refers to times when the waters are significantly cooler than normal. Unofficially, the term for near normal water temperatures is La Nada. Why do we care about water temperatures way off in the equatorial Pacific? Well, as it turns out, the water temperatures can have significant effects on jet stream strength and position due to the changes in thunderstorm activity over the equatorial waters. During El Niño, stronger thunderstorm activity over the warmer waters translates to a stronger jet stream in the southern United States, with a weaker northern jet stream. This often, but not always, results in greater moisture across the southern United States and warmer conditions across the northern United States. During La Niña, the weaker thunderstorm activity results in a weaker southern jet stream and a stronger northern jet stream. This brings more moisture into northern areas, which often couples with greater cold air, while the southern United States tends to be drier than average. Nevada is on the border between significant ENSO regime effects, so strong correlations for El Niño and La Niña are not present. However, the tendency across the Silver Strait is for wetter winters in southern Nevada and drier winters in northern Nevada during El Niño, with drier winters in the south and wetter winters in the north during La Niña. Drier than average conditions are prevalent across much of the state during La Nada, or neutral conditions. Temperature correlations are very weak, but a slight tendency towards warmer conditions exists during El Niño and La Nada, with a tendency towards colder conditions during La Niña. So, what is the current ENSO state? Latest indications from the Climate Prediction Center show neutral conditions both in sea surface temperatures, depicted here over the last year from left to right in different parts of the equatorial Pacific, and in the atmospheric circulation. The latest computer prognostications indicate that La Nada, or neutral ENSO conditions, are expected to continue for the foreseeable future. There is a noted trend towards warmer conditions which might lead to an El Niño by next summer, which could affect winter 2014-2015. As mentioned already, there is not much temperature trend with neutral ENSO, though a dry tendency exists. Just taking a look at Elko itself, during neutral winters, including November and March, temperatures tend to average near normal, though there is a tendency towards a cold midwinter, while precipitation averages below normal. Of note is the possibility, shown in the graph previously, that suggested an El Niño may develop down the road. Taking a look at neutral winters, which were followed quickly by a developing El Niño, the probabilities of a dry winter decrease, though temperature trends are essentially unchanged, if not a little warmer. Some other atmospheric phenomena which might give us a clue as to how the winter will unfold were also reviewed. These include the Pacific Decadal Oscillation, or PDO, the Pacific North America Pattern, or PNA, the Arctic Oscillation, or AO, and the quasi-biennial oscillation, or QBO. The Pacific Decadal Oscillation is, in a sense, the northern Pacific counterpart to ENSO. It is the tendency of above and below normal water temperatures in the northern Pacific, with the phase dependent on temperatures immediately off the west coast of Canada and the United States. It is currently in the negative phase, and based on previous years with similar readings, it is likely to remain negative through the winter. This gives us a clue as to the winter. In winters with similar PDO values to this year's, preceding them, Nevada overall had a tendency towards drier than normal weather. Temperatures were a mixture of above and below normal readings, resulting in essentially no correlation. The Pacific North American pattern, or PNA, is essentially a numerical description of the strength of the ridge over the western United States. When it is positive, a strong ridge is present, generally resulting in warmer and drier weather, while negative values indicate a trough with cooler and wetter conditions. It should be noted that PNA trends leading up to winter are generally not of great value, as they often change and are generally unpredictable in the long range. While not the most valuable source of forecast information, the most recent PNA values were used to compute and correlate upcoming winter trends. During winters following early autumns with weekly positive PNA readings, there has been a strong dry tendency across the Silver State. Temperatures are more difficult to gauge. The Arctic Oscillation, or AO, is essentially a numerical representation of the strength of the polar vortex over the North Pole. During the positive phase, a strong Arctic vortex exists, while during the negative phase, the vortex is much weaker. This has significant effects on mid-latitude weather, but is difficult to forecast in the long term, so present readings are not the best indicator of long-term trends. That having been said, during September, the AO was fairly negative, and comparing previous years with similar readings and looking at how the following winters turned out, we can see that there is a modest warm tendency over Nevada, but a surprisingly strong dry tendency. The quasi-biennial oscillation, or QBO, refers to the periodic reversal of winds in the stratosphere above the tropics. This affects the stratosphere further north, which in turn affects the lower atmosphere. The QBO is fairly predictable and is strongly in the positive phase currently, indicating westerly winds predominate at present. Based on previous years, the QBO is likely to decrease to near neutral through the winter. In previous years where autumn featured a strong positive QBO index, the following winter featured warm weather overall, though a cold early winter was common. A slightly greater than normal probability of drier than normal weather exists during such winters as well. So, looking at these teleconnectors, which years stand out as good matches? 1952, 1959, 1960, 1966, 1990, and 2006 all had similar atmospheric phenomena leading up to the winter, but not all the same aspects in each of those years. Looking at the aforementioned good match years, the following winters featured a very cold period during the early to middle portion, December or January, which resulted in near normal or slightly cooler than normal temperatures overall. This means that the severe cold period was balanced out by warmer periods compared to normal, earlier and later in the season. The precipitation potential looks rather bleak, with most of the years mentioned having below normal winter precipitation. If you match up the long-range predictors as closely as possible, you only get two matches. This is not a statistically relevant sample size, but we plotted the winters following 1959 and 1966 together to see what we got. This combination featured even colder temperatures across the region, with below normal readings likely. There was also an above-average chance of below normal precipitation during the winter, though not as high a chance as the good match years mentioned earlier. The bottom line here is that a majority of analog years based on teleconnections leading up to winter suggest drier than normal conditions are more likely this winter, meaning the drought will likely continue. Temperatures are uncertain, though many analog years suggested a cold early or midwinter period, so be prepared for a period of severe cold in December or January. It must, however, be remembered that this is all a probability game, and the weather has a way of surprising us. Nothing is ever certain in the long term. And, of course, our outlook presented here is an unofficial forecast. The most recent official long-term forecast for the winter period from the Climate Prediction Center indicates an equal chance of above, near, or below normal temperatures across our region. The most recent official long-term forecast from the period winter from the Climate Prediction Center also indicates an equal chance of above, near, or below normal precipitation across our region. This has been a web brief on the winter outlook from the National Weather Service in Elko. For the latest weather watches, warnings, and advisories, please visit our website at www.weather.gov/elko. Thank you for listening.